Hi, this is Harry Forbes from ARC Advisory Group. I'd like to talk for a few minutes about what I'm calling the cloud native tsunami, which is the emerging software architecture for cloud, but also for enterprise applications and eventually for edge applications. Now, it has been my thesis for a couple of years that when Mark Andreessen said software is eating the world, the software that's going to eat the world, in my opinion, has been cloud software. And this is especially true for software development. My thesis is that the methods and technologies people use to develop and deploy cloud software will eventually swallow or be subsumed and take over the enterprise space in our corporate data centers, take over the edge computing space, and even threaten the embedded software space. And each of these domains has different development tools in use now. But my thesis is that cloud software will eventually take over, and the same common development tools and technologies will be used across all of these domains. Now, recently, in mid-November, I attended the KubeCon event in San Diego, the KubeCon Americas event. KubeCon is an event sponsored by the Cloud Native Computing Foundation, which is an umbrella organization under the Linux Foundation that manages a number of open source software projects critical to cloud computing. The growth of this conference has been phenomenal, and the name KubeCon stems from Kubernetes, which is the flagship project of this organization. Kubernetes is a open source software project that manages or orchestrates large numbers of containerized software applications in a distributed fashion. And that can be distributed across a cloud provider or across a cloud provider and enterprise or anywhere. The growth of this conference, as I said, as you can see, has been phenomenal. 5 years ago, the product, or the Kubernetes software, was private and within Google. Google released it about 5 years ago to open source. And since then, the event and the interest in this software has grown exponentially. It certainly seems to me like a software inflection point similar to the ones we've seen in the past. For instance, when Microsoft, with its Microsoft Office, defined and personal productivity applications for the PC, or before Y2K, when enterprises were rewriting their software to get rid of Y2K bugs, but generally leaping onto SAP R2 in order to avoid problems with Y2K. Or maybe a little bit like the introduction of Java, which defined a multi-platform execution environment in a virtual machine. And maybe a little bit like e-commerce, the early days of e-commerce, when the first time that the World Wide Web was linked to enterprise databases and transactions and business processes. So this rapid growth has been phenomenal. Interest in this is open source software, Kubernetes, but it's obviously unsustainable at this rate, or that we'd all be going to the conference. And one thing that's very important to point out with this rapid growth from basically nothing to 23,000 people attending these events is that there's a people constraint in this ecosystem. There is a shortage of people who are deeply experienced. And even some of the exhibitors and sponsors at this conference came to it simply to recruit talented software developers with Kubernetes experience. But you can see that there's not a lot of people in the world who have more than 5 years of Kubernetes experience. In addition to Kubernetes, the Cloud Native Computing Foundation curates a number of other open source software projects. These projects provide services or other kinds of auxiliary services that are required for managing distributed applications. Well, Kubernetes is the flagship product. There are a number of other projects that are in different stages. The CNCF breaks them into 3 areas, which they call graduated for the ones that are ready to be incorporated into commercial products. Incubating, which is a open source software project that is in a more rapid state of development and change. And there's another layer below this, which they call sandbox projects, which are more embryonic projects that are newer and less well developed, still emerging. And of course, there are any number of software projects outside of this ecosystem, but this is a major ecosystem for open source software for the cloud. From the conference, we could see the enterprise impact is still relatively low. In other words, leaders are using this technology now, but in general, it's at its early stages of deployment, even among the leaders, and most of the enterprises have not yet adopted containerized applications for the enterprise and Kubernetes for orchestration. But growth in this area is inevitable. This is, as I said before, like Microsoft Office or like SAP or like Java. It's coming. Even though the penetration is low, leaders are rolling out applications and distributed applications, and managing distributed applications at scale is a very important aspect of software, and Kubernetes is the answer that people are turning to for this. And also these kind of auxiliary open source projects that I mentioned before that the Cloud Native Computing Foundation is curating will grow the capabilities of Kubernetes over time. And so a number of auxiliary services for data storage, for stateful behavior, for communications, networking, etc., are going to supplement Kubernetes and make it more powerful. And at the same time, other engineers are working to make this kind of technology, as complex as it is, easier to use and to deploy. I should mention a couple of vertical industry initiatives in this space where Kubernetes is especially attractive. One of them is 5G telecommunications. And telecom providers are extremely interested in digitizing their services as they move to 5G. Instead of keeping their services at a tower-based cell and providing them with appliances that are dedicated function, telecom providers are now looking to virtualize these network functions and deploy them digitally, so they would have a very large set of applications to manage at huge scale. And so they've turned to Kubernetes to do this. A second area, a vertical area that is important, is the ability to manage new automotive products. And this can be autonomous vehicles, fleets of vehicles, or just vehicles that have much more software content than they used to have. It doesn't necessarily have to be an autonomous vehicle, but clearly you can see that there's a need for these vehicles to manage large-scale software deployments at hundreds or thousands of endpoints, and do so with a very low cost and very high reliability. So there's certainly vertical industry initiatives that are driving Kubernetes from the cloud service providers through the data centers toward the edge. But what about the industrial edge? When we turn to the industrial edge, and this little figure is from Siemens Research, we kind of can divide it into 4 different domains. We really have, in the industrial edge, much more restricted capability in terms of compute, in terms of storage, in terms of networking than we find at a data center, be that a corporate data center, and much less than we find within a commercial public cloud. And we can go a level further and even see within the automation or manufacturing devices, things such as programmable logic controllers, CNC machines, robotics, etc., that there's generally addressed by an embedded system that has a very specific purpose. The difficulty is that in order to deploy Kubernetes and manage containerized applications at scale, we require larger amounts of compute capability and network capability and storage capability than these edge domain and device domain systems really have. So this is an area where there's a big challenge to get this technology into these areas. Why am I so optimistic that it's going to happen? I'm very optimistic that it's going to happen because there are very similar challenges in the two vertical industries that I mentioned, the automotive and the telecommunications industry, because they also have thousands or tens of thousands of small systems on the edge that they need to maintain and deploy software. And that challenge is going to have to be met one way or another. And there's extensive research going on to do that now. So in terms of its industrial and industrial IoT impact, though industrial automation is traditionally a laggard, industrial IoT applications are definitely a target for Kubernetes. And this involves moving orchestrated containerized software to the edge. As I mentioned, both automotive and industrial applications have similar kind of constraints. They have low compute capability, small footprint, and generally they also demand low bill of material costs for the kind of solutions that they provide. So this is a challenge, but again, I think there's a number of venture stage companies and a lot of research going on to bridge that gap, and people are going to find a way to do that effectively. But that makes the future very difficult to map out. This ecosystem is extremely dynamic. As I mentioned, Kubernetes was not even in the public domain 5 years ago. Now it is, and it's, if you will, taken over the mind share in terms of the technology that people are going to use to orchestrate containerized applications. But the next 5 years are likely to be equally revolutionary. So it's very difficult to map out this space and say, here's where it's going to go. But this little quote that I saw at the KubeCon conference was interesting, and I think if you're in manufacturing or manufacturing automation, you'll find this interesting. This is a description of Kubernetes by one of the co-chairs of their architecture special interest group, and I'll read it. The entire system, that being Kubernetes, a Kubernetes deployment, can now be described as an unbounded number of independent asynchronous control loops, reading from and writing to a schematicized resource store as the source of truth. This model has proven to be resilient, evolvable, and extensible. Now, what he's talking about here in terms of control loops are not control loops in the automation sense. They are control loops in the enterprise software sense. These control loops are functions that Kubernetes is doing to maintain a software deployment and monitor the health of this software deployment. So I found this interesting in that at this level, at the deployment level for huge distributed applications, they view Kubernetes as a driver of a large number of independent and asynchronous control loops. It kind of points to me that the same sort of technology could be used to manage other control loops at an automation space in a manufacturing operation. So this leads to an upcoming ARC research topic. ARC is going to begin researching industrial edge orchestration, specifically the orchestration of applications that are distributed in industrial manufacturing, industrial Internet of Things, and infrastructure. Because this state of technology is so early, even though it's critical for the future of industrial automation and for the fourth industrial revolution or Industry 4.0. The field is very dynamic, and it's very difficult to map out this kind of nascent and varied landscape of technologies that we see for integrating this industrial edge and orchestrating it. During this research, ARC will be studying these kind of products and technologies of many venture stage firms, as well as open source projects that are designed to bridge the gap between the cloud and the edge. And these include infrastructure for 5G telecommunications, edge networks, and requirements to manage fleets of vehicles, as well as the networking opportunities that are afforded by 5G itself. And with this industry at such an early stage, detailed market forecasts would be highly speculative and very uncertain. But ARC has decided to map out this landscape, and what we're going to provide as a deliverable for this research is a series of podcasts and webcasts and written deliverables for our ARC advisory service clients as well. So ARC is reaching out now to relevant suppliers, be they hardware, software, or services suppliers in this space, to participate in this research. And if any suppliers are interested in participating in this research, we'd welcome your input. So please feel free to contact me or to contact info@arcweb.com, and we'll be happy to discuss with you this research project. Thank you very much, and have a pleasant day.